In this video, we will introduce regular expressions in Python. We have seen the string data type as well as many of its associated functions. And many of these functions provide useful features such as searching for a certain substring, replacing that substring with something else, as well as some basic text processing functions. In more advanced applications, we would like to search, replace, and look for not only specific values of substring, but patterns of these values within the string. Regular expressions allow us to express these patterns in a special syntax and thus provide a generalization of many of the built-in functions in the string data type. We will introduce regular expressions with some easy examples and then move on to our more advanced examples. That said, regular expressions are by their own a large topic to cover in one lecture. So this serves as an introduction, and your book itself links to various resources as well as refers to dedicated books that talk about regular expressions. Let's take a look at this example here. In this example, we have a line variable, which is this string, and we are splitting it. And you can see that by default, the split function splits around white space. Indeed, the split function doesn't only look for one white space, it can split around multiple white spaces. And if you can see here, all of these white spaces have been consumed when we splitted the string. This is useful as we often want to remove multiples of these white spaces from our string. Indeed, this also works if you have a new line feed. So let's convert this to a multi-line string. And let's have a second line, which is the lazy dog here. If you split, you still get the same result because a split is smart enough to split around multiple of white spaces or different kinds of white spaces. So it's not looking only for a specific character, which is a space. It's basically looking for multiples of these characters. We can achieve the same thing by creating a regular expression that looks for these space characters. Well, with regular expressions, we need first to import the package RE. The second step, we need to express the pattern in what we call the regular expression. So we need to compile our pattern here. Now, what's the pattern that we want to compile? The pattern we want to compile is any white space repeated. Any white space in the regular expression lingo stands for \s and repeated stand for plus. Okay, so let's take a look at this example again. I'm going to run this code and you can see it gets us the same result. Now, let's play with the regular expression and let's play with the line itself. Now, if I repeat this white space many times, you can see that this effectively ignores my repetition because I'm looking for any white space repeated. If I take out this repeated, the plus sign, it means I'm looking only for one single white space. And notice that because I'm only looking for a single white space, effectively it's matching those empty strings, it's matching these multiple times because there are many of these spaces repeated. Okay, so repeated here is important because we want to ignore multiple of these white spaces. Now, similarly, if we have a new line here, \s is going to recognize that new line here because it stands for any white space. So what we're basically doing here, we are re-implementing the split function, the default split function in string. However, if we master this syntax, how we express a pattern of text, we can do much more than the split function provides. That's the basic idea of using regular expressions. We want to go beyond what the built-in functions in the string data type provide. So one function that we extend is the split function. Another function that we can extend using a regular expression is finding whether a string starts with another string. That's the function starts with. Okay, so the function starts with takes a sequence of characters and match it with the string itself. But let's say I want to match a certain pattern rather than a certain sequence of characters. Let's take a look at this example. In this example, I have a list of strings here. And let's say I would like to note which one of them starts with multiple white spaces. Now, if I only know the starts with function for, let's do for each string in this, I can do something like this. If s starts with, let's do one white space, then I'm going to print s and then matches, else print s does not match. Okay, matches. Now, what we're doing here, because we want to print the quotes in the string, we are using a function called representation, REPR, to convert the string to how Python examines the string. This is not a big deal because, I mean, we don't need to make it as it's presented. It's useful to show the quotes. So I'm just going to do REPR here to show the quotes, and REPR there to show the quotes. Okay, so far so good. This one matches one white space here, and this one here doesn't match because it starts with one character. This one also matches because it also starts with multiple white spaces. Now, but this can be sufficient for this simple example. Let's say I want to make this example more complicated. Let's say my pattern I'm looking for is any white spaces followed by A. Okay, so I can do something like this. One white space A, but then none of them will match, although this one should match. Well, so this one is 1, 2, 3 white spaces, so I'm going to make it 1, 2, 3 white spaces. Well, 1, 2 spaces, 1, 2 white spaces, and it will match here. So far so good. How if this string here has 2 white spaces and ABC, and then this one doesn't match? So here I'm limited to define my match using an exact sequence of characters, which may be limited if I'm looking for a pattern. Let's take a look at this example here. And again, don't forget that regular expression here was compiled to using \s plus, which means any white space repeated. So this basically re-implements the function starts with, the basic functions that we have in the string class. So there is nothing here really complicated. It's basically looking for a multiple of these white spaces repeated. And for this simple example, we don't need regular expression. But let me show you how we can use this to solve this problem of this more complicated example. So I'm going now to have ABC, and the ABC with 3 white spaces. And I'm going to tell the regular expression that, you know what, my pattern is now any white space repeated followed by an A. And now you can see that the regular expression now matches this one, also matches this one, but doesn't match this one or this one. So this is really important because it allows us to operate on a pattern rather than allowing us to operate on an exact sequence of characters. Another function here that we can use is the function search, and the function search generalizes or replaces the function's index and the function find in the string. It basically looks for where the pattern exists in the text. Now with index, we were limited, or with find, we were limited to exactly what we were looking for. Okay, but with the function search, we're not limited to the exact sequence. It can be the exact sequence as we see here, but it can also be a pattern. Let me give you an example of a pattern here. Let's say you're interested in matching any word that has O in the middle. So fox is one such word here, but another word here is brown, and another word here is dog. So what I'm going to do here, I'm going not to search for fox, I'm going to search for anything that starts with a character, which is I'm going to do A to Z, repeated, but there is O in between, and I'm going to search for A to Z repeated again. That's going to give me 10 now, because it's going to match brown, and if you count the characters 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The word brown has matched my pattern. And you can also keep searching to search for all of the matches, or there is a function that we will see called find all that will return all of the matches for us, which is great now because we can look for the pattern. Any word with an O in the middle, we can extract it using this regular expression. The function that we will see in a minute is called find all, which basically will give you all of the words that have O in between and sequence of characters, because it matches this expression. So again, with built-in find and index functions in the string data types, we were limited to the exact match. With regular expressions, we're not limited to the exact match. The same thing for replace. We have a replace function in the string data type. There is a function called sub, which substitutes. In difference to replace, it can look for a pattern and substitute it for a string or another pattern. Let's take a look at some more complicated examples here. In this example, we would like to extract emails from a text. So we don't know the email we're looking for. We know the structure, the basic pattern for an email. And the basic pattern of this email is now expressed using the regular expression syntax. There are a couple of syntactical conventions here, which I will cover in more details when we go in the following section, but let's read it now. So what's the email? The email is \w, which stands for any alphanumeric character. The plus means repeated. So I'm looking for any alphanumeric character repeated. @ which is the @ character, and then followed by \w, which is any alphanumeric character repeated, followed by the dot. The dot is escaped because the dot has a specific meaning in regular expression, so we had to escape it. Followed by A to Z, any character in between A to Z, and this character group is indicated using the special syntax of the 2 square bracket, repeated only 3 times here. So if it's repeated more than 3 times or less than 3 times, it doesn't match. And this number of repetition is indicated with the special syntax of the 2 curly brackets. So here you can see that we've got 2 email addresses that match this pattern. If I do email find all text, let's compile email, I get that extracted. Here is an example where I want to mask these emails. I want to search in my text for the regular expression. There is no need to re-specify the regular expression because it's part of this regular expression object. And I want to substitute it with this. So I'm masking any email I match with this text. Now notice that if I do try my regular expression on another text, such as this text, I don't get the email address recognized properly because the way I specified my regular expression was that I was looking for any alphanumeric repeated and then @. So Barak dot doesn't match because there is dot, right? What matches here is Obama because it's any alphanumeric repeated. So I can do better here. I can say, okay, it's any alphanumeric character or a dot repeated. And that will match the email address fine. That's to say, there is an element of trial and error, and there is also the element of understanding the pattern that we're matching for. Even this one will not match complicated email addresses. Okay, so let's talk a bit about the syntax of regular expressions. Again, the sequence of the steps is the following. First, we need to compile our expression, and then we use the expression object to perform operations on text, any text. So, simple strings are matched directly. If I want to match a specific string, I just list what I'm looking for. If I want to match ION, I just type in ION and this is the pattern I'm looking for. Whether I do find all or whether I do search, which will give me the index of ION, search.start, it has two functions, starts and ends, so it starts at 14 character, right? So that's what I'm looking for, ION. Now, we usually do not want just simple characters, because if we are looking for just simple, specific characters, there is no need to use regular expressions. Hence, many of the special characters have special meanings in the regular expression syntax. Let's take a look at some of these characters. Well, first, we need to escape these characters that have a special meaning. For example, if the $sign has a special meaning, which is the end of the string, if I'm looking for a $sign, I need to escape it. If I do something like this, look for $sign, I don't get anything, because $sign means the end of the string in the regular expression. If I want to look for the $sign as a $sign, I need to escape it here. Now, when I escape characters, it's usually a good idea to use what we call in Python a raw string. Now, many often we don't need to have the raw string, but it's really advisable to have a raw string. So let me tell you what a raw string is before we proceed. In Python, when we use escape sequences, and in any programming languages, when we use escape sequences, before the string is registered, the programming language, or the Python interpreter in this case, will go scan the string and will replace the escape sequences with the real character encoding. If I do hi \n there, let's do print here. What I get here is hi enter there, because Python first scanned my string and realized there's an escape sequence, so instead of the escape sequence, it filled in the character encoding of that sequence. Now don't forget, at the end of the day, once everything goes into the memory of the computer, it's encoded using a special encoding. A string will be encoded using an encoding called Unicode, so each character will be, at the end of the day, a number. And the escape sequence will be encoded using the corresponding number of the keystroke. Now, aside from this technical detail, there is nothing here to worry about if we know the meaning of these special escape characters. What if my purpose, my intention was to print hi \n there? There are two ways of doing this in Python. One way is to escape the escape. And if you've done Java, you've probably seen this. Escaping the escape will make this escape the \/ itself \/ and we get hi \n there. Python is not going to interpret it as a new line feed, because this escape, this \/ has been escaped. The other way to realize the same effect is to say, well, suppress interpreting escape characters by making the string a raw string. By making the string a raw string, we're basically telling Python don't replace escape sequences with their actual encoding. Just keep them as they are, verbatim or raw, as the name implies, in raw string. Now, why would you want to do this in regular expressions? Because in regular expressions, we use escape sequences to escape the special characters in the regular expression pattern. Meaning there are two escapes here. There is the escape for the regular expression, and there is the escape for the Python itself. This may be a bit complicated, but let me give you an example here to show you what's in some examples. If you forget to use a raw string, you are in trouble. Okay, so let's do this. Let's say, for instance, you're looking for the \ in your string. Let's say you're looking for the \. I don't know why you're looking for \, but let's do it. Okay, so you can try something like this. Look for a single \ and show me the \ here. Well, that doesn't work here because Python is trying to interpret this as an escape sequence, and there is nothing to escape. It's just complaining. We didn't even run the code. It's a syntax error. Okay, so let's escape the escape now and do something like this. But if you do something like this, this will create an error in the regular expression, because escape is an escape. And what are you escaping? Well, I'm looking for this one. So for this one, you need to have another escape and another escape for the escape, and you get what you're looking for. And I know now you're kind of thinking, oh, what's going on in here? What's going on in here is that there is an escape for Python to get to the backslash, and another escape for the regular expression to get to escape the special character, which is escape. Okay, now I guess you're saying, okay, enough of that. So if you want to look for the escape itself, you know, it should be a raw string, and the raw string will save us the trouble of doing this 4 times. We still need to do it twice because escape has a special meaning in the regular expression syntax. Okay, so long story short, use raw string if you're escaping so many characters. Let's take a look at the $sign again. The $sign has a special meaning. I'm just escaping it. This one doesn't matter if it's not a raw string because there is no escape sequence \$ in Python. But again, to be safe, use a raw string. Okay, let's take a look at this example here. In this example, my pattern is \w, which stands for any alphanumeric character, \s, which stands for any whitespace character, and \w, which stands for any alphanumeric character. So I'm really looking for character space character, which is basically this one first pattern, E space F, this one X space I, and this one S space 9. Now, you may think I will get 9 space Y, but I don't get 9 space Y because this has been already consumed in the previous match. So in the next match, I'm starting here and there is nothing to match. The next match will be S space O. So backslash and one of these letters, it means I'm looking for what we call a character group. \G matches any digit, \S any white space, and \W and any alphanumeric character. And the cap of that negate them. \D match any non-digit, match any non-white space, match any non-alphanumeric character. Once again, take a look at the documentation, and once again, there is so much to learn in regular expressions, and this just kind of scratches the surface of regular expression. So let's move on. If you're not happy with any of these character groups, you can create your own group, and you create your own group by listing characters into square brackets. So square brackets meet any custom character group. And again, a square bracket doesn't mean you're looking for a sequence, it means you're looking for any character here. Any character of A, E, I, O, U. So if you use this regular expression to split this word here, it means you're splitting around vowels. So you get C, and then O is a delimiter, and then NS, and then E is a delimiter, right? And then Q, and then U is a delimiter. You get another E, so there is an empty string in between. Then you get NT, and then I is a delimiter, and then there is an A here, so you get an empty string and L at the end. Now, if these characters are adjacent characters, you can have a shortcut by stating the start and the end in the square bracket with a dash in between. So A to Z, 0 to 9, it means match any character, which is A to Z, followed by any character, which is 0 to 9. So basically, I'm looking for a number followed by, I'm looking for a character followed by a number. So I end up matching G2 and H6 here. Okay, so if I have here, for instance, Z44, I'm gonna get Z4, not Z44, because I'm looking only for one digit after the character. All right, now let's look at another syntax, which is the number of repetition. There are many ways to express number of repetitions in a regular expression pattern. If we know the exact number of repetitions, we can indicate it in 2 curly brackets. Such as in this example, I'm looking for any alphanumeric character repeated 3 times, so I get the, qui, bro, and fox. That's using the function findAll. Okay. Now in this previous example here, just because you see, you're using a different function, which is split. Again, this is different in between splitting and findAll. If you split, you're breaking your string around the pattern. If you findAll, you're looking for the pattern itself. So once again, the pattern is independent from the function you use. Now we're looking at findAll. So I'm looking for this pattern now. This pattern is also repeating the character \W, but it's repeating it 1 or more times. A plus means one or more times. So if you don't know how many times it's repeated, you do \w plus. So if you find all, you're basically looking for simple words because a word is an alphanumeric character repeated many times. So we looked at plus and the two curly brackets. There are more. If you want to repeat from a minimum of m and a maximum of n repetitions, you can put them in a two curly brackets m comma n. If you want to repeat 0 or more times, you do a star. If you want to repeat 0 or 1, you have the question mark. Let's take a look at some of these examples here. That's the previous email patterns that we have, and we have repeated the group 3 times. Now once again, we failed to match this email address because this email address has an extra word in the first part of it. So what I have done here, I included the dot in the special group \w dot and repeated it one or more time. Now, something not related to repeating, you can see that I did not escape the dot here. I could have escaped it if I wanted to, but once the dot is in between the brackets, there is no need to escape it. The regular expression syntax will understand it doesn't mean any character because it's in a character group. But outside of the character group, I had to escape it. Now finally, the parentheses indicate capture group. What does that mean? Well, it means many often we want to match the patterns from our string, but we're not interested in all of the pattern. We're interested in sub-pattern, or maybe we're interested in breaking the pattern further down. Parentheses allows us to break the pattern into groups, and we will get these groups captured for us. So in this case, let's say we are interested in extracting the username as well as the domain name as well as the domain type, right? So I broke it's the same regular expression as in above, but I surrounded these groups with parentheses to put them in capture group. Notice that the @ symbol is part of the expression, the dot is part of the expression, but I don't want to capture it. So what I have here when I find all, let me compile my regular expression, I have the email broken to 3 components: username, domain name, and domain type. If I don't care about, for instance, the domain name, take out this capture group. I'm gonna get the username and domain name. That's to say I don't care about the domain type. And similarly, if I don't care about the domain name, I just want the username, I can extract it in its own capture group and I get one username in this case. So this is very useful because it saves us the time to process the result of the regular expression. We'll say, for instance, you want to extract the username from emails. So step number 1 is to extract emails. Step number 2 is to extract username from emails. So this saving us the effort of pre-processing the results because we can put those in their own capture groups.